All right. Hello, everyone. Welcome to day 2 of KVM Forum. My name's Alex Bennée. I'm a developer at Linaro. I've been working on QEMU for the last 12 years. So it's my turn to give the report on the last year's activities. So I thought I'd start with a bit of a high-level overview. So the raw numbers, the last year we've done about 7,500 commits, about 640 developers have been involved, and we are sticking to our regular 3 releases a year. That seems to be going like a metronome. I wanted to get an idea if we were seeing a fall-off in contributions or how development was going. So this is a plot of the last 3 years of data. Because of our release cycle, it's actually quite noisy. So this is a rolling 4-month average, which is basically our release cycle. And as you can see, it's fairly steady. We're seeing a fairly consistent rate of commits. I think that slight fall-off in contributors at the end is just a rounding error due to the rolling average. So I did this diagram last time I gave the talk. So this is a tree map diagram for all the changes that we've done in the last year. So the sizes of the blocks is basically related to the number of lines changed, and the color of the blocks is the number of commits. So you can see that bright yellow block over there on the right. That's the root directory of the source tree, and that just gets hit more than all the other areas of the source tree. If you follow the QR code, you can have the fancy animated version, and you can dive down and see all the individual bits of the tree and where the activity is. So that's the raw data. But I wanted to take a slightly different approach this year and look at the zeitgeist of the project. So zeitgeist is a wonderful German word. It means the spirit of the time. And English being the language it is, we do like to borrow words from other languages, so we have it now. So I thought I'd have a look at what's been going on in the project by looking at mentions of QEMU on Hacker News. So for those that don't know, Hacker News is a fairly sort of geek developer-focused website, similar to the Slashdot of old. And this is the top 6 stories over the last year that mention QEMU. So whilst we're going along, you can play a little game, see if you can guess which story is the top story. So we'll start with the bottom, story F, Rust in the QEMU roadmap. So Rust is a very zeitgeisty language itself, so whenever Rust gets mentioned in relation to other projects, it usually attracts quite a lot of interest. We introduced Rust as an experimental build option last year, and in that time, we've done a bunch of work. So we've got bindings for QOM and QDev, which are the sort of key parts of doing any device emulation. We've got bindings for the character device subsystem, bindings for logging, and there's some initial work going on C-Rust data interoperability. So that's making sure that C and Rust have the same view of what a string is, things like that. And we're quite close now that you can write a fully safe device model. So basically write a device model without having to rely on little unsafe hacks in Rust. This is the activity over the last year. As you can see, fair amount of stuff going on. The one thing I will point out is we've got a relatively limited contributor pool. So this is an invite to anyone that's interested in exploring what you can do with Rust in QEMU. Please get involved. There's a bunch of interesting talks about it later today, so if you're interested, go and see that. Right, next story. VirtIO, Vulkan support for the VirtIO GPU. So I will preface this by saying I'm not a GPU expert, but just briefly, why is Vulkan interesting? So this is a modern GPU stack. It's the next generation on what OpenGL offers. It has potential for being more efficient for virtualization, because unlike OpenGL, which is very sort of scene-focused, Vulkan gives you the sort of low-level bits to draw something, so there's less explicit synchronization points. But it does mean the toolkits have to deal with things like fencing. And perhaps the most interesting thing about Vulkan is it offers an opportunity to do standardized compute. So GPUs, they're not used just for doing pictures anymore. They're increasingly used for things like machine learning. And usually that involves having some vendors specialized library optimized for their hardware. But at least with Vulkan, you could abstract this away in a virtual machine. It does bring some interesting challenges. So one of the things that the Vulkan support brought in was blob support. And this allows you to map chunks of memory from the host system, usually the VRAM inside your GPU, and then make that available to the guest. And that introduces some challenges and care. Mainly means you need to have a quite bleeding edge stack to get everything to work. So you definitely need a 613 kernel or better, because you need those PFN map fixes to make sure that the host doesn't swap a page out from under the guest whilst you're trying to do something. You need a modern libvirtual renderer. You need recent Mesa with the Venus support turned on. For QEMU, it introduces a slightly tricky threading model because libvirtual renderer runs in its own thread. So we're constantly passing memory back and forth between the QEMU processes and libvirtual renderer, and that causes a bit of friction with the way that we like to track our memory regions, especially because memory regions used to be static things that were part of the machine and now are becoming more dynamic things that change over the lifetime of the run. I'll just quickly mention some other options. So we also have support for Rutabaga, which is something Google submitted that can also encapsulate Vulkan as well as other protocols. The main challenge with that is that you need a number of libraries that aren't packaged routinely on distribution, so you have to build your libraries yourself. And I'll also give a shout out to the vhost device GPU, which is a vhost user backend that's part of the Rust VMM project. All right, next story. Emulating the iPhone in QEMU. This is actually so good it appeared twice. It only appeared once when I ran the scripts 2 weeks ago, but I foolishly ran the scripts again this week. And I thought, that's interesting. We can't emulate iPhones in QEMU. That's right, we can't. This is not upstream. Now, we don't usually talk about downstream forks because that's not what we're about, but I thought we'd have a quick look. This is mostly the work of 4 authors. They've been keeping up, tracking the latest QEMU source tree. It's about 50,000 lines of code, 1,500 commits, and this is broadly what it takes to emulate an iPhone in QEMU. As you can see, mostly ARM hardware and all the Apple silicon. They've done a few tweaks into the target ARM support stuff, and USB for some reason. I thought I'd take this opportunity to have a little bit of a look at the wider ecosystem of QEMU. So I did a query to GitHub to list all the forks. It doesn't quite give you all of the forks. You have to do a little bit of manual tweaking of the data. But just to show how widely forked QEMU is downstream. So the size of the blobs is basically the size of the project. The thickness of the line is how much has changed. And then the color is based on the timestamp of the head commit. So you can see projects like, for example, Panda here, forked quite early on in 2.9, but still actively developed. And then you can see, I mean, the big one that's really noticeable is the Android emulator, forked to 8.2, and massive, massive changes that Google have made for their thing. All right, I'm running short of time, so we will move on. The next story, again, don't rerun your scripts the week you're going to give the talk. QEMU 10.1. So, hot off the press, I didn't have much time to prepare anything for this, so you get a nice, pretty word cloud. If you want to see the details, as I'm sure you know, you can just read the changelog. All right, so we're ready for the top story. Anyone want to guess what it is? No? The AI policy that we introduced. So, I mean, it's hard to live in the tech world without having AI impinging your life some way. But basically, the TLDR, which is in our code provenance document, is currently the QEMU policy is not to accept AI-generated code into the project. This mostly comes down to our interpretation of the DCO, or the Developer Certificate of Origin. So this is the thing that you implicitly agree to when you add your signed-off by to the commit. And what you're saying is that you have the right to submit this under an open source license. And the problem from QEMU's point of view is at the moment there's a lot of legal uncertainty about how copyrightable AI-generated code is and whether AI generators are violating other people's copyright. And it's not something that the QEMU project wants to take on as a legal risk, certainly at this time. Importantly, the policy doesn't limit you from using AI for other things. So if you want to research APIs or ask it to help you with your debugging, if you think that will help, doing static analysis, things like that are still perfectly allowed. And it's just as well, this presentation, about 50% vibe coded. I don't spend a lot of time with Python, so occasionally I do ask the AI to help me get started. But importantly, I think this is a policy that's likely to evolve as the tools mature and also as the legal situation becomes more clear. I thought I'd just quickly talk about what some of the other projects are doing. So LLVM, they're fairly liberal in terms of accepting code that's been generated by AI, but they're very clear that contributors submitting code must verify its correctness and must understand what it's doing. They realize that having people send low-effort patches that they don't understand basically puts a massive burden on the maintainers, and that's something that's not really sustainable for an open source project. The kernel is still discussing what their policy is going to be, but one of the proposals is to add a code developed by tag, so the models would automatically tag commits, saying which model generated the code, and that would at least give traceability in the code base so you could see where code came from. I've mentioned libcurl here because it's a fairly popular user space library. Again, they have a fairly liberal approach to accepting AI contributions, but they make it very clear that you need to meet all the other requirements. Just because it's generated by AI doesn't mean it can't be, or it must still be written clearly, must be understandable and documented and have test cases. I've added a link here to Daniel's blog about another problem they have, which is the death by 1,000 AI slops. So one problem libcurl has is a lot of CVE submissions, so potential security bugs, that are basically low-effort submissions generated by LLMs, and then it's taking a lot of time for the maintainers to review those and often find that it's actually not a problem, but they've wasted a bunch of their review time. So finally, I gave this talk about 3 years ago, and that was just when image generation was starting off, so this QEMU on the left was what I originally got out of DALL-E. Fortunately, I saved the prompt, and I ran it through Google's latest one, actually. I think it's called Nano Banana. So I leave it for you to judge whether AI has got better or worse at appreciating what the author has asked it to do and done a better job. Finally, if you want any of the graphs of the data, how this was generated, if you follow the link in the slides, you can get to my org workbook and then have a look at how everything was put together. All right. Thank you very much.